Welcome to the AI Research Roundup. I'm Alex. Today, we are looking at a paper from the Hugging Face trending list, published on September 2nd, 2025, just yesterday. The standout move is a clear reframing of language models as agentic policies in partially observable worlds, showing how reinforcement learning turns planning, tools, memory, reasoning, self-improvement, and perception into adaptive behaviors. The paper is titled, The Landscape of Agentic Reinforcement Learning for LLMs, a Survey, and the implications for model training are quite significant. The survey also compiles open environments and benchmarks, contrasts single-step LLMRL with full POMDP setups, and sketches challenges for reliable, scalable agents. Also, the authors shared an official GitHub repo. Listeners will find a curated, constantly updated awesome list for Agentic RL with LLMs, organized by tasks like search, coding, GUI, multi-agent, plus environment benchmarks and frameworks. It includes links to papers, code, some model checkpoints, and a detailed README with tables and categories. So the figure sets the scope clearly. The focus is how reinforcement learning enables language model agents to act in dynamic environments, while topics like value alignment, non-language model reinforcement learning, and pure benchmark boosting sit outside. Dynamic environments means settings that change over time, so choices have delayed consequences. Figure 1 also outlines the survey structure, which progresses from formal foundations to capabilities, applications, tooling, challenges, and conclusions. So Figure 1 maps the storyline of the survey into a branching roadmap, which signals how the discussion flows from foundations to practice. The left spine lists the big sections, and the right branches expand into concrete subsections. This figure shows 3 main clusters: foundations from LLMRL to Agentic RL, capability modules like planning and memory, and task domains such as search, code, and math. The bottom branches cover environments, frameworks, and challenges, which frame how results are evaluated and scaled. So Figure 2 highlights the shift from single-step language model reinforcement learning to agentic reinforcement learning, which treats the model as a policy acting with both text and executable actions over time. The left bands show static setups with direct feedback, while the right expands to dynamic environments that evolve, so long-term exploration matters. The middle wedge emphasizes text plus action, meaning the agent can plan, use tools, and manage memory. The top arc lists concrete implementations, benchmarks, and algorithms that operationalize this shift. So the table spells out the core difference. Traditional preference-based fine-tuning treats training as a single move, while agentic reinforcement learning treats it as a multi-step interaction with changing observations. This table shows that actions expand from only text-to-text plus tools, transitions shift from fixed to dynamic, and rewards move from one number to stepwise signals. The objective also changes because outcomes accumulate over time, which pushes the agent to plan. Alright, 2 takeaways stand out. Reframing language models as agents in partially observable worlds makes reinforcement learning the engine that turns planning, tool use, memory, reasoning, self-improvement, and perception into adaptive skills. And the compiled environments and benchmarks give a practical runway for scalable, trustworthy agents. Thanks for listening. I am Alex, and this was the AI Research Roundup.